students? So now let's continue with the top-down parser. So I said the top-down parser, that is a recursive descent, is of two types. One is with backtracking and without backtracking. So now let's see the concept of backtracking. What is backtracking? The parse tree is started from root node. The parse tree is started from root node and input string is matched against the production rules for replacing them. What it means? What do you understand from this definition? So here they are saying that the parse tree, whatever you are going to construct, that parse tree is started from root node. So you have to take the root node, means the start symbol of your grammar, and input string is matched. So whatever the input string that we are given, that string has to be matched, means the terminals has to be matched. So again, as the production rules for replacing them. So first you substitute one thing, whether the tree is forming the it gets the input string reached or not. If not, again go back and take another grammar and substitute in that. Okay, until you have to backtrack until the input string is matched. Okay, so let's see the example, then you'll get a clear idea of what exactly the backtracking concept that we used in the recursive descent, that is the top-down approach. Let's take the grammar. Let grammar G be S tends to CAD. X tends to CAD and it's a small c. A tends to AB or D. Okay, and W, whatever the string that is the input string, you will get is CAD. So this is the final string that you need to get. W is equal to CAD. There's a small c, and here A and S are the non-terminals. So in place of A, you can replace AB, or in the place of A, you can replace D. But the thing is, we have to get W is equal to, okay, W is equal to AD. Okay, let's construct the tree. So according to the concept, what is that? S is CAD. So that is a starting node, that is a root node. So you have to start the tree with the help of the root node. That is S tends to S produce CAD. S produce CAD. Okay, let me write the productions here. CAD. A tends to AB or G, and W tends to CAD. Okay. So it's not CAD, it's CDD. We have to get the CDD. Now let's see. So this is the first step. So in place of A, first substitute AB. Let me substitute AB. In place of S, I am substituting S, C. In place of A, you need to substitute A and B, and this is D. So is it matching with the input string or not? Let's check. So what is the string, final string you get? That is W is equal to CABD. So is it matching with the input string? No, it is not matching. So what you have to do? Again, you need to backtrack. So next write another production. So in place of A, I am writing D. Replace A with D. Okay, and D. So this is the next production. So now check, is it matching with the string? C is it tends to produces C, D, D. Okay, it finally matches the input string. So then your production is completed, means your parse tree is completed. So when up to when you have to be repeat this process until it matches the input string. So here root node contains a start symbol S. The body is begin with the C, okay, which matches the first symbol of the input string. So which matches the first symbol of the input string. Next, his non-terminal, that is a non-terminal which is having two productions. So here is A is having two productions. One is AB and another is the D. Okay, so first you can take a first production, that is AB. First take the first production A. So which results CABD. Okay, CABD. So that does not matches with the given string CAD. Okay, CDD, it does not matching to the given production. So what you are doing, again you need to backtrack. So just backtrack that, and this time backtracking to previous step when the A gets expanded and try with alternative production of it. So this production, that is a W is equal to CDD, that matches the given string. Okay, so that matches the given string. So this is about the backtracking. The main concept of the backtracking is you need to backtrack until you will the result of the tree is matching to the input string. Okay. So here also some limitations are there. What are the limitations of using the backtracking? The limitations are, if the given grammar, whatever the grammar that we are taking, if the given grammar has more number of alternatives, suppose here only two alternatives are there, so then it is easy to find out whether the string is matching or not. If in the case there are more number of productions are there, if the grammar has more number of alternatives, then the cost of the backtracking will be high. Then the cost of backtracking is high. Okay, that is the main limitation of using the backtracking. If only the two productions are there, then it is easy to calculate, check whether the string is tree is matching with the input string or not. So whenever there are so many alternatives are there, so if it is not matching, okay, then go for another production. If it is not matching, again go for another production. So then the cost of backtracking is very high. Thank you.